Do you know what is more painful than losing everything in a sudden market crash? It is when the fragile global supply chains shatter, the power grid goes dark, and that expensive high-tech water purifier sitting on your kitchen counter turns into a useless piece of plastic, all because you cannot get on the internet to order replacement cartridges. The modern survival industry wants you to believe safety is something you buy. They sell you a shiny plastic housing and lock you into a perpetual subscription model. But when a major disaster hits, store shelves empty in hours. You cannot order anything when cell phone towers are down. Today, we are going to flip the script. We are going back in time to steal the survival technology that kept ancient Roman legions marching and soldiers alive in the disease-ridden jungles of World War II. We are going to build a bulletproof, off-grid water filtration system using an ordinary, unglazed terracotta clay pot. It costs almost nothing, uses zero electricity, requires no monthly cartridges, and will outlast you. Building a water filter out of baked earth sounds like a ridiculous trick, but emergency hydration is a brutal, unforgiving science. The secret behind this ancient magic is simple. Fired, unglazed clay is essentially a rigid, rock-hard sponge covered in millions of microscopic pores measured in microns. Most harmful bacteria, like E. coli or cholera, and parasites like Giardia, measure around 1 to 3 microns. The pores in properly fired, unglazed terracotta are smaller than that. When you pour contaminated swamp water into the clay pot, gravity forces the water molecules down through those microscopic winding tunnels. The water passes through, but the bacteria and parasites are simply too fat. They act like giant boulders trying to squeeze through a chain-link fence. They get trapped on the surface, while crystal-clear water sweats out the other side. No moving parts, no chemicals, just gravity, earth, and time. But hold your horses. Do not run down to the local hardware store and grab the first orange garden pot you see. That is a fantastic way to trade a bacterial infection for heavy metal poisoning. Modern manufacturing standards for flower pots are vastly different from food-grade ceramics. The biggest hidden enemy is lead. Some natural clay contains heavy metals, and overseas facilities might use lead-based molds or toxic additives. Furthermore, pots shipped across the ocean are sometimes heavily sprayed with toxic fungicides. You must source your terracotta wisely. Look for pots made in countries with strict environmental regulations, like Italy or Germany. The most important rule of all is that the pot must be entirely unglazed. If it has a shiny, glass-like coating, it will not work. That glaze seals the pores, making it waterproof. You need raw, highly porous terracotta. To be certain about safety, buy a swab-style lead testing kit. Swab the inside and outside. If it tests positive for lead, smash it and throw it in the garbage. Once you have a pure, unglazed pot, you are ready to build. The most urgent question is about that giant drainage hole right in the bottom center. If you pour dirty water into a pot with a massive hole, the water will flow straight through, completely bypassing the clay walls. Your very first step is permanently plugging that hole. Put the duct tape away. This must be watertight and food safe. The best modern method is a high-quality, food-grade silicone sealant. Squeeze a generous amount into the hole. Use a piece of broken, unglazed tile or a clean, flat stone as a backing plate, and let it cure completely for 24 to 48 hours. For a totally off-grid method, drive a tapered natural cork tightly into the hole from the inside, then melt pure beeswax heavily over the cork to create an impenetrable seal. Whichever method you choose, test it rigorously. Fill the pot to the brim with water and watch the plug. If a single drop leaks out of that hole, your filter is useless. Water should only weep slowly from the outer surface of the clay. Now you need a catchment system. The absolute easiest setup is a food-grade, 5-gallon plastic bucket with a tight-fitting lid. Cut a large circle in the center of the bucket lid, just slightly smaller than the widest diameter of your terracotta pot. Rest the pot securely in that hole, so the bottom half hangs down inside the bucket and the rim catches on the lid. This prevents dirty water or dust from falling into your clean water below. You can drill a small hole near the bottom of the plastic bucket and install a cheap plastic spigot for dispensing. But listen carefully. You cannot drink that first glass. Your brand new pot will make the water taste like a muddy puddle. The kiln firing process leaves microscopic clay dust and ash trapped inside the pores. Take a stiff wire brush and scrub the inside and outside of the terracotta pot under running water. Do not ever let soap touch this clay. It will absorb the detergent, and your water will taste like dish soap for 6 months. Just use physical friction and hot water. After scrubbing, run at least 3 to 5 full pots of water entirely through the system and throw that filtered water away. By the 4th or 5th run, the water will run crystal clear and taste clean, crisp, and slightly earthy. At this point, you have a functional biological filter. But we need to talk about what it does not do. The clay acts as a biological wall, stopping bacteria and sediment, but it does not stop dissolved chemistry. In an urban disaster, a flood, or a grid-down scenario, you will face industrial chemicals, pesticides, and automotive fluids. The ceramic stops the biology, but it ignores the chemistry. To fix this weakness, add carbon. You can buy bulk granular activated carbon online and store it indefinitely. To create a dual-stage system, add a carbon layer straight between the sweating clay pot and your clean water bucket. Hang a stainless steel mesh sieve or a food-safe cotton bag filled with washed activated carbon directly under the drip path. Every drop of water will slowly drip through that bed of carbon, which acts like a chemical sponge, trapping toxins, chlorine, and heavy metals. If you cannot buy activated carbon, make standard charcoal yourself. Build a hardwood fire, let it burn to black solid coals, crush them into small gravel-sized chunks, and wash away the white ash. A thick layer of hardwood charcoal will still perform excellent chemical filtration. You have just replicated the exact process used in the most expensive commercial filters. Now, we must address the invisible threat: viruses. Critics point out that viruses, like hepatitis A, are astronomically small, sometimes as small as 0.02 microns. They will slip right through the pores of a standard terracotta pot. However, viruses typically become a massive threat only when human sewage mixes directly with drinking water, like during a major urban flood. So, how do you adapt your primitive filter? You use the clay to do the heavy lifting, and use chemical or thermal treatment for the final mile. If you try to boil muddy floodwater, you waste precious firewood heating up liquid dirt, and you end up drinking hot mud. If you put bleach into muddy water, the dirt instantly consumes the chlorine, rendering the bleach useless. But, if you run that muddy water through your terracotta filter first, the clay removes all the dirt, parasites, and bacteria. What drips out is perfectly clear water. Because the water is clean, bringing it to a rolling boil is incredibly fast, saving your limited fuel. Alternatively, add exactly 2 drops of plain, unscented household bleach to every liter of that clear filtered water. Because the sediment is gone, the bleach is 100% effective at hunting down any microscopic viruses. Stir in the 2 drops, wait exactly 30 minutes, and the water is absolutely sterile. The ceramic makes the water clear. The boiling or bleaching makes it sterile. Long-term maintenance is critical. Water plus clay plus time equals life. If you leave a wet terracotta pot sitting for a month, green algae and a slimy bacterial biofilm will form. Every few weeks, or when the flow rate slows down, clean the system. Scrub the outer and inner layers vigorously with a stiff brush to remove the trapped sediment and expose fresh pores. To deal with anything growing deep inside the thick clay wall, you need extreme heat. Because terracotta is baked earth, it can handle high temperatures. Every few months, after scrubbing, let the pot dry completely. Place it directly into your kitchen oven and slowly bring the temperature up to 350 degrees Fahrenheit for an hour or 2. This dry sterilization completely incinerates any organic matter trapped deep inside. Let the pot cool slowly, and your filter is essentially brand new. But heed this life or death warning regarding freezing conditions. If your terracotta pot is fully saturated with water and the temperature drops below freezing, the water inside the microscopic pores will freeze, expand violently, and completely shatter the pot from the inside out. Even a microscopic hairline fracture destroys the integrity of the filter, and pathogens will flow right through. If you use this in winter, keep it inside a heated space. If you lose heat, drain the filter and allow the clay to dry completely before the hard freeze hits. A bone-dry pot survives the harshest winter, but a wet pot will be permanently destroyed by a single frosty night. Finally, let us talk about the flow rate. Getting 1 gallon of clean water every 4 hours requires immense patience. To safely speed this up, you must increase the head pressure, which is the physical weight of the water pushing down on itself due to gravity. If you fill the top pot halfway, water drips very slowly. If you fill it to the brim, the sheer heavy weight of that tall column of water forces the water at the bottom through the clay much faster. To maximize this physics trick, buy the absolute tallest, narrowest, unglazed terracotta vessel you can find. A tall cylinder creates significantly more downward pressure than a wide, shallow bowl. Another practical approach is scaling up. Instead of forcing one pot to work faster, set up 3 or 4 tall terracotta pots in a row, all dripping simultaneously into a single large catchment trough. By running multiple filters in parallel, you turn 1 gallon every 4 hours into nearly a gallon every single hour, enough to sustain a large family. The unglazed terracotta water filter is a raw tool. Its effectiveness depends entirely on your knowledge and discipline. If you source pure clay, plug the hole perfectly, prime the system, add carbon for chemical threats, treat the clear water for viruses, and rigorously maintain it with heat sterilization, you have armed yourself with one of the most resilient survival technologies in human history. True self-reliance is not about buying the most expensive gear in the catalog. It is about applying the right knowledge to the raw materials immediately around you. A piece of baked earth, some crushed charcoal, a little household bleach, and a deep understanding of how they work together can provide absolutely safe drinking water for your family when the rest of the world is desperately waiting for a rescue truck that may never come. Go build one of these resilient filtration systems this weekend. Source the right unglazed pot. Seal the bottom hole perfectly. Test the physical flow rate. Taste the crisp water. Figure out exactly how to set up your carbon catch basin and practice sterilizing the clay in your kitchen oven. You need to build the necessary muscle memory today in the comfort of your home, with the warm safety net of running municipal tap water backing you up. Because when the grocery store shelves are violently stripped bare and the city taps finally run completely dry, you want a massive, bulletproof system already set in place and working flawlessly. You want to be sitting on your porch, drinking crisp, clean water, while everyone else is just getting incredibly thirsty.